Hey, good morning. So, yesterday, or the last time you did this, we looked at graphs and equations of quadratics. Hopefully you got better. Gosh, that all ties back to that very, very first day of kind of looking at the forms and making it work. Well, instead of doing a sketch, now be very careful. When I asked you to do something like that, I'm sketching it. If I ask you to graph it, that's where you're using the Desmos. You're kind of using the technology to get it exactly right. You got to have the feel, and you're going to find that when we go talk about this thing called the discriminant. It's so much better to just have a feel of what's happening rather than, oh, where does every point go? And you kind of lose the purpose of the power of the mathematics. All right. Hey, simple task today. I'm going to give you a picture. You're going to write an equation. Okay, then. Well, here's the art. The art is I'm going to give you quadratics, and really the key is which form should you pull the information from and just plug it in. So if you understand this first one is the vertex form, and you're given a vertex, wow, you're so ahead of me. All right, and maybe if you understand P and Q are the roots, because this is factor form, life's good. And to be honest with you, the standard form, really kind of hard to just look at a quadratic and write it in standard form. So, just kind of giving you something to lean forward to there. We're going to do a few examples, and then I'll get out of your way. All right. So find the equation of the quadratic graph with the function. All right. Or I'm sorry, find the function for the graph. So we'll do two. I will tell you right here that the first thing you need to do is lean back and say, what do I notice? Well, I hope you notice that there's a root here at -1, and there's a root here at 3, and then the y-intercept is 3. But I'm going to take you another step on that y-intercept. Think of it as just another point on the graph. It just happens to be the y-intercept, and that implies that the coordinates are 0, 3. 0, 3. All right, well, let's see what we can do here. Might have to just show you both of these at the same time, but that's okay. So on the left here, notice we have two roots, -1 and 3. Therefore, I'm going to choose, this is the math. If you ask me what the math is, it's not adding and subtracting and multiplying. That's a pretty fun technique. But the math is the thinking. Which way should I go? Which direction? And some days you'll be right. Some days might not work out. So here's our factored form. Understanding P and Q are our roots. We already have two of those things outlined. That is amazing. So all you got to do is plug it in and realize that A value. Okay, so a lot of people will just write this down and say, I think I'm good. But the A value, remember, allows us to do a lot. It makes us switch, do this, flip it upside down if it's negative. So there's a lot of control with A. Well, to get A, all we need to do is plug in any point. Do we know any other point? We don't have to know the y-intercept, we just have to know any other point. And in this case, we know 0, 3. 0, 3. So we're just going to plug in 0 for x and our 3 for y. Then we're just going to multiply that out, and we get A equals -1. Now that makes a lot of sense, because if we go back and show you the graph, remember it was opening down, so we should expect a negative number. Our final answer is going to be -1 times x plus 1, x minus 3. Mr. Sayers, I think I got it. You look in the back of the book, and they don't have that written. They have -x² something something. All they did is multiply it out. I think some people are running into that and trying to make the connection. If you want to multiply this out and make sure you get exactly what they say, great. If you want to leave it in that form, I think for me, it tells me that, hey, you're thinking about it. You've picked that form. It's the best. So feel free. Hey, I'll just run through that other example. That was annoyingly over here. Notice the roots are at, so this is kind of interesting. Notice the roots here, 2, but there isn't another one. It's actually called a double root, so you can consider that thing twice. So when we say it has a double root at 2, we can still use this factored form. Notice we have the y-intercept at 0, 8. And when you plug that in, you can use that root twice, since it's tangent at the x-axis, since it's called a double root, sometimes a multiplicity of 2 because it's a double root. Cool. So once again, we are in the exact same situation. We have everything except for A. I wish I had a point to plug in. I do. 0, 8, and we are off to the races. Plugging and chugging. Bad place to make a negative error, so kind of catch it out. Should it be positive? Yeah, it opened up, so that's a good check. I'm just going to plug it in and call it good. Some people might notice this is like a vertex form. It's kind of like, but Mr. Sayers, there's nothing out here. That's that +0. So you could say the vertex of this thing is at 2, 0. 2, 0. Could you have done this a little different way and got the exact same thing? Absolutely. So if in your mind you're like going in that direction, go that direction. That's the beauty about math. Some days you can go from Pooter to McDonald's in Campus West 2 different ways. You could go, cut through Taft and on Elizabeth, or maybe you go north to Laramie over to Cheyenne and back. But at the end of the day, you might both be there at McDonald's. And some days it's going to be a little longer. That's all right. Let's check it out. All right. So in this next example, I don't want you to look at the writing. I want you to think. Always think what you know first. Well, I know a root. That's awesome. It looks like this is the y-intercept. So instead of saying the y-intercept is 16, I'm going to say it goes through the point 0, 16. That's pretty powerful. And annoyingly, I only know the x-coordinate of the vertex. The x-coordinate of the vertex. Well, is there any forms that require the x-coordinate of the vertex, 1 root, and 1 y-intercept? And it's like, that's weird. I don't know. So you write down what you know. Yeah, you're thinking, you're like, thank goodness Mr. Sayers is giving me this example because I'm a little, symmetry. Such a beautiful, beautiful thing in mathematics and in the world. We have bilateral symmetry, right? One side of our face looks something like the other side of the face. Nature got it right. So let's use this beautiful thing called symmetry. And what I mean by that is everything's symmetric about the axis of, wait for it, symmetry. So if we are -3 away from the line of symmetry here, then we're probably +3 away from this one. So that makes that other root 4. So with a little Encyclopedia Brown, a little detective work, we can find the other root. Probably don't need to do the rest of this problem because you're going, wait, Mr. Sayers, I know 2 roots and I know a point. Isn't this exactly like now what we had before? You bet. You bet. So we'll run through it real quick. I would pick that form. I would plug in my 2 roots. I would plug in my point that I know, 0, 16. I would evaluate A. I'd get a negative, and that makes a lot of sense because that thing opened down. And then I just plug it in. Life's good. Moving on. Sorry. No picture. Holy mackerel. All right. Find the equation of the quadratic whose graph cuts the x-axis. So this is like the 5th way of saying a root, a 0, an x-intercept, that cool point, whatever you want to say. We know it cuts the x-axis at 4, -3. So we're already probably thinking of the form that we want to use. They give us a point. This is why I was stressing that it doesn't have to be the y-intercept. All it needs to be is another point on the graph. In this case, x equals 2 and y equals negative 20. Awesome. Give your answer in y equals that form. Hey, don't fall for it. That doesn't mean we have to create the quadratic using this. That means it has to end up like that. So let's go with what we know. I would definitely use those that form again. Notice how I'm working with the signs. It's x minus the root and x minus the root. So x minus 4 and x minus a negative 3 gives me that plus 3. Now I need to find what a is. I plug in the point 2, negative 20. Boom. Hey, be careful. Don't want to mess things up here. Going slow, showing my work. And I get a equals 2. And it does. That feels good to me that it opens up. So my answer that I would be happy with and the world would be happy is this. But the SAT would not be happy because they asked the form. So how do you get it in that form? You just multiply it out. Multiplying is an easy direction. Rewriting it the other way, factoring, that can be a little sticky. But you guys showed me some amazing techniques on that homework. So really good. I hope that helps. Last one. Save the. This is usually the, now let's get into the hardest ones. You guys had way too good of teachers last year. You know the vertex form. You're given the vertex. You're given the vertex. I would go ahead and use the vertex. So there's the vertex form. You have to know what h and k are. They are the actual x and y coordinates. So I just plug in a positive 3 in for h, and I plug in that negative 2 for k. And look, we are in the exact same situation. We don't know what a is, but do we know another point on the graph? And we do. It is the y-intercept, so x equals 0, y equals 16. Just plugging it in. Go slow. Make sure your negatives are right. Look at that. Oh, it's going to be a whole number. You know it's right when that works out so well. Don't be afraid of fractions. It's kind of 2 for 1. They're almost better than whole numbers. There's my a. There's my h. There's my k. I'm done. If they wanted me to write it out in ax squared plus bx plus c, I would just multiply it out. Have a fun time doing that. And that's all good. Don't know if I'll have time to make this a play positive. If I do, I'll have you do this problem. If I don't, then you can email me and tell me what you thought. All right, under 15 minutes, doing well. Oh, your homework is going to be these problems. Let me go ahead and type that in right here. It is going to be section 1E. I would like you to do 1D, 2B, 3BE, and 4BE. Mr. Sayers, that is only like 6 problems. I apologize. If you want to do more and you want to feel the rhythm, you can. It's an art to give out the right amount of homework, but I think those will certainly get you feeling right. It's a short assignment because I think I'm going to give you a play posit tonight, and we're going to start that process of getting the video before class, doing a little warm-up in class, and then having that time in class to work, ask questions, maybe do a quick exploration. All right, you guys take care.